exponential function. It involves an exponent, but the difference is the exponent has a variable. So it's a times b to the x. A and b are going to be some kind of numbers, and then the x would be your power. So your variable is the exponent. So that's an exponential function. All right. As it turns out, if that b is a number bigger than 1, so 2 to the x, 3 to the x, 4 to the x, then that is what we call exponential growth. And we can kind of think about that. If I say my function is 3 to the x power, okay, if my exponent is 1, 3 to the first power is 3. If my exponent is 2, what is 3 squared?
6, 9.
If my exponent is 3, what's 3 to the third?
12. 27.
27. So my y values are growing. So that's exponential growth. And so when we look at it, the function is increasing. It's getting bigger. But if that base is something between 0 and 1, so if, for instance, I said 1/3 to the x. All right, so if my x is 1, 1/3 to the first power is 1/3. If my x is 2, what is 1/3 squared? So that means 1/3 times 1/3. 1/9. What is 1/3 to the third power?
127.
And so what's happening to these numbers?
Going down.
Right, those are getting smaller. So if you have a number, a base between 0 and 1, that is exponential decay. And it will be decreasing. So growth, they're getting bigger, it's increasing. Decay, they're getting smaller, it's decreasing. We are going to see something when we graph these that's called an asymptote. So an asymptote is a line which the graph gets close to, but doesn't touch. Okay, so it's going to be getting closer and closer to those lines, but it won't ever actually hit the line. That's an asymptote. Okay. So we are going to look at a graph for some of these and answer some questions about that graph. So my first one, y equals 2 to the x. All right, all of the functions we're going to look at today, we're going to do some fairly straightforward. We're just going to graph them and answer some questions about those. So if I look at that, if we want to graph, what do we need?
X and Y.
We need some x's and y's, right? So we need some points. Okay, if we put in 0, what is 2 to the 0 power? 1. Anything to the 0 power is 1. If we put in a 1, what is 2 to the first?
2.
If we put in a 2, what is 2 squared?
4.
Let's try some negatives. If we put in -1, what is 2 to the -1?
1/2.
2 to the negative 2.
1/4.
You can use Desmos with this as well if you want to help graph. You can certainly use the graphing calculators, but Desmos does a much better job of kind of showing us the graph. Why don't we pull that up? Right. As this goes on to the right, it's just getting bigger and bigger and bigger, right? But as it goes to the left, what's happening?
It's small.
It's getting smaller. Now, will you ever do 2 to a power and get 0 for the answer? No. That negative is going to make it 1 over something. It's getting close to 0, but it never actually hits it. So our graph, we have some points. It's increasing. This side, it is flattening out. It's getting closer to the x-axis. It's not really turning into a true horizontal line, but it is flattening out. The x-axis is what's called an asymptote there. I could even draw that as kind of a dashed line just to show you we're getting close to that, but we're never going to hit it. We're never going to cross it. That's as close as we get. So is this one growth or decay? Yeah, as I went from left to right, it was getting larger. Or you could look, my base was bigger than 1, so it was growth. My domain, on all of these, can I put in anything I want for x?
Yeah.
Domain is like saying, what are possible x values? Or if I look at this graph, it's like saying, okay, if I start on the left and go for the right, can't I do anything I want?
Yep.
Okay, so my domain is everything, all real numbers. You can write all real numbers, or there is a symbol for it. It's like an R with 2 bars. That means all real numbers if you want a shorthand. Range is saying what kinds of y values can we get. So domain is talking about x, and range is talking about y. When I look at this graph, do we ever have any negative answers? No. Do we ever have 0? No. But we have all the positives, right? So my range, my y values, y is greater than 0. Make sure you're jotting this down. You're going to want to look back at these when you're doing your homework. All right, what is a y-intercept?
Yes.
What's the y-intercept?
The 1, 2.
Where it hits the y-axis, right? Where does this one hit the y-axis? At 1. Or if you gave me an ordered pair, it would be the 0.01. Okay, the asymptote. That line that we were getting close to but not actually hitting. Think back to our first unit. Horizontal lines or equation is y equals a number, right? What's the y equal to on that line? Y equals 0. So horizontal line we're not actually touching. All right.
It's easy.
Questions on that one? Let's graph another one. When you are graphing these, you have to make sure you're plugging in some positives, some negatives, and 0. Okay, so I usually, we did like -2, -1, 0, 1, 2. That's going to be a lot of points, and you can certainly use Desmos to kind of double check your graphs on these and see if it's lining up. So if I put in a -2, what is 1/4 to the -2? Everybody has a calculator. Everybody can answer that.
Why are you not starting at 0?
You can. I was just saying you have to put in some negatives too, so it doesn't really matter what order you put them in.
I got 16.
1/16.
Gave us 1/4 to the -2 gave us 16. Can I even go that high on my graph? No. Okay. What happens if I do 1/4 to the negative 1? 4. So negative 1, 4. What is 1/4 to the 0? 1. Anything to the 0 power is 1. What is 1/4 to the first?
2.
If I put 1/4 to the second, 1/16. Can I even? I could, but that's really, really hard to graph, isn't it? It's just really small. So a lot of times on these, you're going to get numbers that are kind of hard to graph. Make sure -1, 0, and 1 are probably going to give you some pretty reasonable numbers. After that, it just kind of depends. Let's double check ourselves on Desmos. If I wanted to graph this, like I said, you can do the graphing calculator. Desmos just gives us a little bit clearer picture. If I want to type that in, I would do parentheses 1/4. Does that look kind of like we have our points? Yes. So strongly encourage you, look at Desmos to double check yourself and help on that homework. So when I look at this one, just do your best. I know it's hard to graph with those points. Make sure it's curved and make sure it's getting closer to the x-axis but not actually touching it. Okay. So is this one growth or decay? Is it getting bigger or smaller? It's getting smaller. So this one is decay. And we can tell because 1/4 is smaller than 1. If your base is smaller than 1, it will be decay. Hello. All right, thank you. All right, what's my domain? It's going to be the same on every one of these problems. What was it last time?
All real numbers.
All real numbers. On any of these, you can plug in whatever you want for x. So you can write the words all real numbers, you can write the symbol, doesn't matter. It just means you can put in anything. My range, what kind of y values am I getting? I'm getting things bigger than 0, right? Y is bigger than 0. Okay, my y-intercept, where does this graph hit the y-axis? At 1, same as the last one. Or if you want to do an order pair, it's the 0.01. All right, asymptote. Where is that line that we're getting close to? Same as the last one. What was it? Y equals 0. So these things, they have a lot in common, don't they? Domain, range, y-intercept, asymptote. Wasn't that the same on both of these questions? Yeah. Okay. Let's look at the next one. We'll see how far. We'll do at least one more, maybe 2. Okay. If I graph this one, we have to put in some negatives and positives. So let's try a few points. -2, -1, 0, 1, 2. We know we might get points that are hard to put on the graph. We'll do the best we can. The more points we have, the better. But what resource are you going to use to help yourself? Desmos. Use that to look at these graphs. You know, when you take the EOC at the end of the year, you can use Desmos. So use that nice, pretty graph to help you. All right, if I put in -2, grab a calculator if you need to. You have 3 to the -2, and then a -1. Go ahead and just give me the decimal. What does it give us? Somebody can say it.
I only know
-0.8 repeating. We
Only
put
have
in,
fractions for those.
yeah, you can do a fraction if you want. You do 3 to the negative 2 minus 1. If you do the fraction, you have negative 8/9, so either one.
Cause that's just like positive. You just gotta switch them.
So negative 2, I'm getting some decimal that's close to negative 1, but not quite. If I put in negative 1, so I get 3 to the negative 1 minus 1. That's a negative 0.6 repeating, or a negative 2/3. So I'm still getting a negative, but not quite as small. If I put in 0, 3 to the 0 minus 1, what do you get? 3 to the 0 is 1, minus 1 is 0. If I put in a 1, 3 to the first is 3, minus 1 is 2. If I put in a 2, 3 to the second is
4. No.
9, minus 1 is 8.
I don't know. I'm guessing.
Okay, let's kind of look at this on Desmos. We have 3 to the x minus 1. Okay, so does that look like our graph? All right, what is this growth or decay? Growth. It's getting larger as we go. What's the domain? Every time, no matter what. Okay, but my range, this time we do have some negatives, don't we? Whereas all of these numbers are bigger than what? They're all bigger than negative 1. Yeah. That minus 1 on the end affected it. So my range would be y is greater than negative 1. Y-intercept, where do we hit the y-axis this time? 0. My asymptote, it's always going to be a horizontal line, y equals. But this time it's not y equals 0. Where is it?